Hello everyone. Today we are starting our new elective course on radiation physics. It's an elective course for M.Sc physics course in Calicut University. I myself, Dr. Mohammed Rasi, Assistant Professor, PG Department of Physics, Syllabus Science College. So here is the basic structure of the course and the syllabus and some references. So we have 5 modules: radiation source, interaction of radiation with matter, the second module. Then we have radiation quantities, unit and dosimeters, and the third module, biological effects of radiation, will be covering in module 4. And in module 5, radiation protection, shielding and transport will be discussed. Okay. Then the main reference for the first 2 modules are GF node, radiation detection and measurement. Then K. Thailand's basic radiological physics. Then Sayyid Naeem Muhammad's physics and engineering of radiation detection. So which is one of the main reference I will be following, physics and engineering of radiation detection by Sayyid Naeem Muhammad. So which is I found it's much convenient and better understanding, easy understanding. You can just follow it up if you find it useful. Of course, we will be covering the parts of node and thyroid also in the sections. So today I will be giving a brief introduction of the course. Then I will be discussing about the module 1 on radiation source introduction part. Okay. So we'll just move to the sessions. So here is my plan of talk. I'll be talking about the scope of radiation physics first. Then we'll try to understand what are radiation is there. Then types of radiations. Then ionizing and non-ionizing radiation. So we'll be discussing those 4 parts today. Then followed by other things we'll be discussing in the following lectures, inshallah. Okay. So the scope of the subject is that radiation physics has finding a lot of application in terms of medical diagnosis, treatment, space exploration in industry, and radiation chemistry and electricity in terms of power generation. That you are already familiar with the controlled fission reactions happening in IG Kapalpakam, and radiation spectroscopy, where you can use the radiation as a tool to identify and trace different elements in the body parts and different other elements. And dosimetry is another area that you will be extensively discussing in the later modules. It's about how much you are affected and how much the biological effects has been happened in the body can be traced using. It's another field of radiation. And agriculture and archaeology is then archaeology, especially on carbon dating, is another area. And again, if you want to say much about medical diagnosis treatment, you are familiar with many treatment. Radiation is one of the main tool for cancer and all. So in all aspects, finding abundance of applications for the development of mankind, and there are plenty of applications that are upcoming. Of course, when you are discussing about radiation, the first thing will be striking at your mind will be about the radiation hazards, right? So radiation hazards will be the main thing, because this symbols is familiar wherever you are having a radiation hazard, especially on the X-ray machines or the radiation sources or reactors. You are familiar with this quotient. So many way radiations has been misused, that you already know about the atomic explosions, and the different other regions of the world has been affected with the radiation. Of course, taking apart these all hazards of radiation aside and misuse of radiation, you can clearly identify that it is having a much useful in a field of physics, and especially for the world of finding utilization of this radiation physics. So who are interested in radiation physics or will be finding interest after covering this course can take a course by BAR. It's a diploma in radiological physics. You can do it after your M.Sc physics, and you can take a radiation safety officer as a profession in hospitals and medical physics, and oncology department as a medical physicist. So this is one of the highly paid professions in this area. So the final point I want to make about the scope of the subject is that clearly this advantages outweighs all its disadvantages like radiation hazard, misuse of radiation hazards. It can find plenty of applications towards the development of our daily life purpose. Okay, so that's how radiation is useful. We already know that all time we are surrounded with many radiation, like from our phone, like from our radio, like and many other sources we already covered with. Even our sunlight is a electromagnetic radiation. This all having a, we already surrounded with radiation. How it hazardous, how it differently classified, those all things will be discussed. This is the first part of this session. Okay, so we'll move to the water address water radiation is that. That's more important, right? So we need to identify what is radiation is all about. Okay. So what are radiation? Radiation. Before going to radiation, we need to talk about something about Einstein's mass energy relation. So what is Einstein's mass energy relation? It's talking about the relation between matter and energy. So matter and energy is the quantities that is made up of its entire universe. So Einstein has introduced E is equal to mc square, which actually relating this mass and energy. So of course we know matter can move from one place to another place, and also energy can also propagate through any media. So we are already familiar with the lights and all. So we know that energy also can propagate like matter. So what is radiation is all about? Radiation is all about, we can say that it's a radiation is the transportation of matter or energy through a space. So why I have put particle in wave nature? So it can have a particle also wave nature. Whenever we are talking about energy, so the first thing will be coming into mind is about light. It having a wave like propagation of light will be coming in. So we know that Max Planck has given an explanation for that, which having also having a particle like nature for light. And De Broglie in later in 1920 also said which this particle also having a wave-like nature as well. Lambda is equal to h by p, where lambda h by p can be further can be written lambda is equal to h by mp, where what m is the mass of that particle. So that means there is a for every mass there is a wavelength is associated with that. That's called De Broglie wavelength is all saying about. So ultimately, what is radiation is that radiation, of course, when energy is emitted by a source. So whenever some source is emitting energy, then it travels through a medium such as air until it's absorbed by a matter. So what is the absorption of matter? What is the interaction of matter with the radiation? We'll talk later. So basically, we can say radiation is the transportation of matter or energy through a space. Okay. So now we just taken a small exercise which is about related to De Broglie wavelength. What we want to do is that compare the De Broglie wavelength of a proton and an alpha particle moving with the same speed. Assume the velocity to be much smaller than the velocity of light. Consider the mass of alpha particle to be about 4 times the mass of proton. So you just take this consideration. Just try to compare the De Broglie wavelength of proton and De Broglie wavelength of alpha particle by considering mass of alpha particle as 4 times the proton. Okay, hope you can do is that. So finally what you want to end up is that it will be giving a value of lambda proton will be equal to 4 lambda alpha particle. So the wavelength of proton particle will be approximately equal to 4 times the alpha particle wavelength. You just try this exercise and try to get me your response in next session. Okay. So we move to what are the different types of radiation. We understood that radiation is a matter of transportation of matter energy through a space. So it can have 2 possibilities, right? So it can have a particle nature and a wave nature. So radiation can be in the form of particle or wave. So that's a point I want to also make. So it can have a particle nature and a wave nature. So that's the first kind of classification we can make of radiation. Second one is that, as you familiar, radiation have hazardous and non-hazardous. So in that respect, you can classify the radiation as hazardous or non-hazardous. And third one is that radiation you can classify the ionizing or non-ionizing. Whether you can remove an electron from an atom, or the radiation can either cannot remove an atom. So based on that ionization process, you can classify ionizing and non-ionizing radiation. This is the one we'll be discussing much detail. Okay. Then we have ionization radiation. These are the different examples of different radiation: ionizing radiation and non-ionizing radiation. So I said that in ionizing radiation we have particle beams and electromagnetic waves. Okay. So we have a charge in that. Even in particle beams we can have an explanation of charged particle beams, and in that actually the classification is directly ionizing radiation, and we have an indirectly ionizing radiation which is classified as uncharged particle beams. Okay. So we have in charged particle beams we have alpha particles, which is actually a helium nuclei with 2 proton and 2 neutron. That is called a alpha particle means. Then we have beta particle. A beta particle is similar to electrons. So electron ejected from a nucleus is called beta particles. So this both will be getting from an alpha decay and a beta decay process happening at nucleus. Then we have a few other charged particles like proton beams, neutron beams, heavy ion beams. Then we have a charged meson beams. Then finally we have a fission fragments. Fission fragments like which are the 2 nuclei split from a nuclei. Like if you have a nuclei, spontaneous fission is happening, then you can get a 2 separate nuclei. That means 2 separate atoms. So those 2 separate atoms are called fission fragments. So this fission, spontaneous fission process is a technique it useful for producing neutrons. This we will discuss in the later slides. Then we have an uncharged particle beams. So which is a indirectly ionizing radiation, which are called uncharged meson beams. Neutrinos are there, which is a low reacting one, low interacting neutrinos, which having a, we already know that it's having a charge of electron charge. So it's we have a neutrino of positive and positrons are there, and neutrinos are there. So we have a neutron beams. Neutron beams also actually which is produced in a nuclear reactors and accelerator, which is also classified in terms of uncharged particle beams. So there are 2 types of ways that we have particle beams classified into charged particle beams, then uncharged particle beams. Then also ionizing radiations have electromagnetic waves as well. That means it having a waveform as well. So which is an indirectly ionizing radiation like X-rays. So which is generated outside the nucleus. Then alpha, gamma rays. X-rays are generated outside the nucleus. That means it's producing in a orbital of electrons. An electron is leaving from the one orbital by ejected from some source. Then there will be a radiation emission will that is called X-rays. Of course, we will be having a discussion on this all in more detail. Then non-ionizing radiation, which is called classified as electric waves, microwaves, infrared waves, visible rays, and ultraviolets. Finally, I want to make a point is that this all classification actually based on the properties and interaction of majority particles. Maybe all the particles in a group cannot be involving in working as a particle or a wave. So if you take a collection of particles, in that some particles radiation, in that some may be particles, some maybe can be represented as a wave, some may be hazardous, some may be not hazardous, some may be leaving our body without making any signature, some group of particles may be giving some effects on our body. Like so all the particles may not be ionizing also, may not be having the property of ionization, but majority of the particles can be having a ionizing or non-ionizing properties. Okay, so then what is ionizing radiation and non-ionizing radiation is that it's a radiation has a mover. So main point of classification is the types of radiation on basically on ionizing radiation and non-ionizing radiation. So that's a more our interest of discussion. So what is ionizing radiation is that it's a radiation has enough energy to remove electron from an atom. So it can either produce from a natural and an artificial source. So what is a natural and the artificial source of production can be discussed in the next session of this module. In that classification, we have a cosmic rays, nuclear plants, and X-ray machines are some sources of such a ionizing radiation protection. And this type of process is called ionization. Radiation has enough energy to remove electron from an atom. Okay. Then we have non-ionizing radiation, which does not have energy to remove electron from an atom. So such examples are radio waves, ultra waves, UV rays, microwaves, and sunlight. Okay. So you can see a familiar picture that I will just represent here the electromagnetic spectrum. In that up to UV, from extremely frequency from up to UV, we are having a non-ionizing radiation. Then above that X-rays and gamma rays is there, which is about ionizing radiation. So which is a low energy region while non-ionizing. Ionizing having increasing energy region. So which have a capacity for remove electron from an atom. So which is called, why it is called ionizing radiation. Okay. Now we have what are the different sources of such a radiation can be seen here. So for extremely low frequency we have the power lines. For radio waves we have AM radio, FM radio. For microwave we have a microwave oven or like our phone, everything else. And radiant of heat, wherever we have heat production, we have infrared waves, one of the source like handbox, we are very familiar. Then arc welding is one of the process where you can identify this UV and this both sources together. And like medical X-rays is one where position where you can identify X-rays. Then we have radioactive sources where you can get a gamma rays. So these are the different classification. One point always I want to say that we all know that radiation is not something that very far from us. It's already surrounded with many equipments that's already working around us. So which all are emitting radiation. Even our light itself electromagnetic radiation. So in that, since it's not harmful, it's not ionizing, which is not much affecting us, but ionizing radiation like X-rays and gamma rays, which actually make some change in our body, so that is make it much more hazardous to us. So of course the abundance of radiation emission and exposure can have some effects on our body that already you are familiar with the UV rays effects and some microwave effects. Of course, the main idea of this course is to address the radiation in detail and what is the different types of radiation, how the radiation is interacting with the matter and what are the changes is happening with respect to that. And before that we need to identify what are the different types of radioactive sources for the charged particles and the radioactive sources for the electromagnetic waves like X-rays and gamma rays. So that will be the main highlight of this session that we will be discussing on the next section. Okay, so this part of the section is about types of radiation, non-ionizing, ionizing radiation, different particle and electromagnetic waves, charged particles and uncharged particles that we already have discussed. Then finally, summary of this session is that radiation is a transport of matter or energy through a space. There are three types of classification based on its form, hazardous or ionization can be there. Then it have both particle and wave nature. Okay. Then ionization and non-ionization waves can be seen. Then the majority this classification is based on majority particles, properties and interaction with the body. Okay. On all, the advantages outweighs its disadvantages. Hope this lecture is fine useful for you. Try to understand. We have just given a brief introduction about the course and the brief introduction about this module. So just try to understand what are the radiation, what are the type of radiation, how do the classification, what are the different particles, what are the charged particles, uncharged particles. Next, as I said, we will be discussing about the radioactive source of each one, how the radioactivity and radioactive decay will be working as a source for different particle beams and electromagnetic wave radiations. Okay, thank you for its listening. Okay, of course we'll meet in the next lecture soon. Okay, thank you all.